Hi, my name is John Joyner. I'm a Azure and Security MVP, and it is my pleasure today to present to the Cyber Back to School viewers the October 31st, 2025 session for Cyber Back to School 2025. This is the final day of a month of sessions, and my topic today is Microsoft Defender for IoT, and happy Halloween. So, a very tiny bit about myself. I work for a company named Accountability. Uh, there's our website address if you want to know more about us. We're an MSP and MSSP using the tools that I'm going to be describing today to manage our customer OT. Uh, I have I'm an ex U.S. Navy commander. I did network security then, and I'm still doing it today with Microsoft tools. On the left of the screen, you can see the cover of my latest book on Azure Arc and the links to my LinkedIn profile and my blog. So if you want to continue a dialogue, if you have any questions arising from this, uh, I'm happy to answer any questions, do any follow-up. The best way to reach me would just be a DM from LinkedIn. Today we're going to talk about Defender for IoT, the OT security, industrial security product from Microsoft, which is a part of the Defender XDR family. We're going to do a high-level, brief OT overview and an interesting, hopefully interesting discussion on IT versus OT security. We're going to talk about the customer challenges that were expressed when Microsoft has been doing the product development and how that those are all met substantially by the product. And then we're going to go deep and rapidly into the Defender IoT architecture. And by the time you've seen the slides and the heavy demo content, you should be able to really picture in your mind each piece of the IoT solution and what features they map to. The Defender for IoT integrated with the Defender XDR, all of the tools in the Microsoft Security Cloud, including Microsoft Sentinel, achieve the IT OT convergence that is required. That we'll get a little bit of discussion of this later, but hopefully you'll get an appreciation that deploying this tool is going to give you rapidly, highly actionable insights to address security shortfalls in your industrial systems. It's an amazing product. So I do have a AI generated image for this slide to demonstrate what could go wrong. What a bad guy can walk into your shop floor and hook a device up to a switch port or something else and break in the old-fashioned way. But as we'll see later in the session, this is not exactly the most common vector. In fact, inside physical security break-in jobs like this in the OT world are less than 10% of the cases. They are most often not this scenario, but this is certainly one that you can imagine. That you don't want somebody to just come in and plug a device into your OT network. Would this solution alert you when an unseen device connected to the network and started poking around the network? Absolutely. This situation will alert you in real time to if the event seen in this drawing actually happened, right? If you're a manufacturer, your manufacturing plant is your crown jewels, and Defender for IoT is the guardian and does a great job. Operational security is industry specific. Because it always involves a machine. There's always an endpoint, which is not a traditional computing device, but is a machine or device that executes instructions and can be programmed and communicate with other devices. There we go. It's a build slide. Um, The types of industrial control devices in the upper right-hand corner, your program logic controller, your PLC. This is the most common device. In this case, you can see it's a mod. In this particular photo, it's a vendor's modular collection of devices, serial ports, controllers, connectors, network cards. The PLC is purpose built for the machinery and industry that it's going to be working in. And we have other devices that we encounter doing our OT security or administration. For example, the HMI, the human machine interface, and the EWS, the engineering workstation. These are computers that have special roles as defined in the Purdue model, which is the segmentation model for OT networks. And in addition to this late addition to this list, building management systems, growing use case in the IoT sector. So these are the devices that we need to protect. So here's that discussion that I said we were going to have on the differences between IT security and OT security. IT security, we're concerned about data confidentiality and privacy of our users. That's our number one concern. On the OT network, it's safety and availability. You don't want to hurt anyone, break anyone, and we want the machine to be up. Uptime more important than privacy. Your IT, in the enterprise IT world, you are going to be generally machines are designed to talk to the internet and other machines across a wide area network, whereas your OT networks are traditionally air gapped, and if not air gapped, they're deeply firewalled, and by design, there's no mixture of industrial and non-industrial resources. Your IT LAN, standard protocols and devices, your Ethernet, Microsoft networking, etc. It's a standard set of protocols for almost all the devices on the network. Whereas in OT security, in 1,000 devices at a customer, there might be 300 different types. So there's a high variety of endpoints in the solution. And finally, in the IT security world, we're used to having lots of monitoring and management and IDS and probes and things to make sure that our networks are healthy and not being broken into. Whereas on the OT side, there's often very little general network monitoring, surveillance, and appropriate security measures like that we can deploy with Defender for IoT. Who's attacking OT? This is where I said, the rogue insider, that's maybe 3%, less than 10%. Look at the main bad actors in OT attacks are geopolitical. They're nation states. Who are they attacking? I said, OT security is industry specific. And this list, short list of industries, includes most customers that have industrial devices, control devices that need to be monitored for availability and security. What kind of devices are being attacked? The PLCs, the first instrument in the list of in the diagram with a different kind of list of devices. I mentioned they are the most common and they are the most attacked. You can see thermostat on there, right? Thermostats are present in all kinds of environments, from HVAC systems in buildings to ovens in industrial bakeries. So, a bad guy can study all the thermostats that out there and find one with the weakness, and then find his way into a company that has the vulnerable machines and do bad stuff, right? So I think this is interesting to ground ourselves in the attacks that are coming to the OT world, because they are a little different from the ones that are attacking in the enterprise world. So I mentioned that I would have a slide that talked about challenges that OT customers reported to Microsoft when Microsoft was developing their plan strategy for this product. And I believe that every single one of these customer needs is met by the product. The first being asset discovery, and as I mentioned, this product above all, or not above all, but first of all, is going to give you a great sense of accurate insightful ownership of your plant. It's going to discover everything rapidly, sort them by what they are, what they're doing, and then from that moment, nothing is going to drop out or be added that you're not going to be aware of if you're watching the product. Everything that is discovered is watched for vulnerability management. Specifically, there's several features that help you when you have many thousands or even tens of thousands of devices, and there's maybe 100 of those device families that have urgent vulnerabilities to be fixed, and you're just like, where do I start? I'm going to show you the tool provides that prioritization and even a work plan to continually reduce your risk and to vulnerability. And then in the lower right, this bullet is basically, yes, all the power of the Microsoft Cloud for vulnerability management and detection is going to be applied to what's observed happening in your OT plant. This one over here on the right, Microsoft, better than anybody, it meets the requirement to achieve effective IT OT convergence in the cybersecurity world. Many modern OT devices, they need to phone home. They may have a requirement to get to the internet that previous ICS devices did not require. And so there's definitely a need for businesses, for organizations with IT and OT networks to manage them effectively. And since they're often utilizing some of the same equipment and internet routers and firewalls, managing through the same pane of glass just makes sense. I think this slide is really valuable, and I've got the URL link to the website that this information came from. These are the alert categories that come from the Defender for IoT sensor products. So when you're monitoring the traffic happening, the networking events happening in your OT network, you're going to get alerts when things happen in these categories. For example, internet access. If a machine accesses the internet that hasn't before in a certain manner, you'll get an alert. If programming instructions that normally have a certain format are anomalous, or there's evidence of failures or client devices rejecting programming instructions, you'll get alerting of all that. Suspicion of malicious activity, brute force attack, all of these aspects of your environment are going to be watched. And so, being familiar with this list lets you know that Microsoft is watching all of the telemetry that could be considered due diligence and appropriate. You're getting your money's worth. It's looking for what you're paying for it to do. So I mentioned the Purdue model a bit, and not every customer has their devices segmented in this model. The Purdue model has down here in the process control network the actual sensors, the PLCs doing the work, talking to the machines, actuating, getting the temperature sensing, getting the data from the sensors, sending instructions to the robotics. And these devices are what's called the process control network, and that's where our HMI has access to. And then our engineering workstation, these two devices, types of devices, as well as the historian, which is an archive database of OT records. These are recognized administrative roles in the Purdue model. In the Microsoft IoT solution, we put a sensor down here in the supervisory network, and that sensor has a SPAN port connection to the network switch that the process control devices are connected to, and it is through the mirroring, the promiscuous spanning of the traffic from those OT devices network that are passively consumed by the IoT sensor. That's how we watch the network. We watch it indirectly by getting a copy of all the network streams of all the devices sent to us, and then we analyze it. So here's what a sensor looks like. This is a small footprint physical sensor. This is a micro PC, and the key thing about it is that it has two network ports. The minimum for an IoT sensor is one network port that is essentially connected, that has outbound connection to the internet, so the device can talk to the Azure cloud. And then the other the other physical port, and there could be more than one NIC or a virtual NIC in a physical or a virtual sensor. These go to span ports. These go to the ports on your switches that are designated to mirror the traffic that is coming from the OT devices. You're going to see the sensor itself quite a bit in the demo coming up. You'll see that you can communicate with the sensor through SSH through a telnet PuTTY session when you have to for initial configuration. And then generally, when you need to access the sensor directly, it'll be through the sensor's web interface. So here's a drawing of the lab environment. When we go to the demo, you're going to see all of these things exactly. So the Purdue model is respected with 3 levels of firewalls between the supervisory network and the internet. We have our Defender for IoT sensor. So this is that little micro PC that you saw a second ago. This is that micro PC that has one network card on the it has one network card on the supervisory network with the route to the internet through the firewalls, and the second network card is connected to this span port. So in this drawing, you can see a serial controller server, you can see a Siemens PLC, and that these devices are connected to these ports on the OT network switch. And if we inspect that switch's configuration, which you're actually going to look at in a quick second, you'll see that these ports are selected to be mirrored to this port. Right? So it's in the switch configuration that the magic starts. When we talk about the sensors, the sensors can be physical, they can be virtual. What we were looking at just now, it was an L100 hardware sensor. It was not this exact model from this company, but it was from a competitor. And having done this, I can tell you for small capacity offices, basically any rugged micro PC that you trust that has 2 physical NICs is going to work. You basically load a Linux image onto onto your own physical device, or you can pre-purchase physical devices from Dell and HP. You can see the different form factors and then the number of devices, so you can monitor up to 12,000 OT devices with one of the high-end hardware devices from HP. You can also have virtual appliances. If you have healthy Hyper-V or VMware ESX-based virtualization assets at the locations where your OT devices are, you can deploy your sensors virtually, and then you have to cable your host, your VMware host, or your Hyper-V host. You have to cable one or more of the physical NICs of the hosts to the span ports, and so it requires a little careful configuration of the networking of the hosts, but it's absolutely supported virtual as well as physical, and you can have a mix of them in your environment, and you just either buy the right size pre-configured appliance from Dell or HP, you buy appropriate sized hardware device of your own and install the image, or you deploy a VMware or a Hyper-V guest and deploy the image. Those are really like the 3 paths to creating a sensor that you can then physically place near your OT assets and cable up as needed. Defender for IoT is licensed through the M365, through the Office 365 admin area. So even though it's the OT is like a enterprise, it's not generally what we would consider like on the user side, but that's actually where the licenses are purchased. So whoever in your financial operations purchases your Office licenses, it's in that same area that you would purchase your Defender for IoT OT site licenses. And in this case, in the lab environment, we have the smallest license called the XS license, which is 100 devices. And it's the licensing is monthly with a 1-year obligation. So the smallest sensor costs $70 a month in OT license times 12 months, so it's about $800 and $840 is the buy-in for a sensor. Like you really can't use the product outside of a trial environment with any lower cost. Here's that view of the switch port that I mentioned. So this is an HP switch, the management application reached through telnet to the switches, a little compute. And in this case, I see ports 1, 2, 3, 4, 5, 6. They say monitor. And then monitoring enables yes to port 45. So in this case, ports 1 through 6, which our OT devices are connected to, are being mirrored on port 45, and we connect the span port of our sensor to port 45, thereby listening to everything happening on these other 6 ports where the OT devices are. The OT sensor itself, what's running inside that Linux image, a Debian Linux image, are actually Kubernetes containers, and the containers are called engines. That's why in the demo I'm going to show you a little bit the file system of the Linux running on the sensor, really just for interest, because you're never going to touch that thing. You have to the only way to administer it is through the command line menus and the sensor's web UI, and of course through inheritance of policies and settings that are enforced at the Azure portal level, where the activation file comes from for each sensor. And with those, the engines running in those little those containers on the sensor are doing things like looking for anomalies, looking for malware. They're engines that are tuned to do these types of work because they're different workflows, each type of investigation. The remember the first operational requirement that people told Microsoft is, hey, I want device inventory. I need to have a handle on what I've got, and this is what it looks like, right? You're gonna have the Defender for IoT is going to discover the device. It's going to make a pretty good guess of what type of device it is, because the product is aware of the Purdue model. And it's going to listen on the network wire, and it's going to cleanly tell you these are the protocols that we see coming from or going to this machine. So that's all information at the top level inventory. And here's a couple of features that we're going to show in the demo. These are the mapping features of the sensor. Sometimes there's no substitute for a graphical display, and this product does it extremely well. The device map feature is really in my estimation, is about the only super high value feature of the solution that's not available in the portal or when connected to Sentinel, that you have to actually log into the web interface of the sensor to interact with these device maps. And we'll dive more into these in the demo. Here I had it in the slides demonstrated, basically the built-in subnets for the process control network and the supervisory network. You're going to see those live in the demo in a minute. So connecting Defender for IoT to Microsoft Sentinel, think of it as just fast forwarding to the end state of Defender for IoT when it's fully migrated to the Defender XDR console, which you're going to see this quite in detail in just a minute in the demo. And because I want potential customers of the Defender for IoT product to understand that the best thing to do is to deploy Defender for IoT along with its other cousins in the Microsoft suite, because within a year time frame, the Defender for IoT product is going to be another first-class citizen in the Defender XDR console, and these other features that might right now reside in the Sentinel console. Again, in a year, the Sentinel console and the Defender for IoT console are all in the same console, the single pane of glass of the Defender portal. So this is a very high value integration when you connect Defender for IoT behind Sentinel. I'm going to mention in the demo, I'm going to show you the Content Hub, and you're going to see these analytic rules and logic apps and workbook that are installed when you connect Sentinel to Defender for IoT to Sentinel. This is a workbook out of Sentinel. There's various dashboards and workbooks available in the solution on the sensor, and in the Defender for IoT product has its own workbooks. This is a workbook that you only get when you hook up to Sentinel, and it's the most full-featured dashboard workbook for the product. And so again, like, why not make this connection between Defender for IoT and Sentinel to like light up these very high-value dashboards and other integrations? Here's a incident in the Sentinel console. You're going to see this in depth. This is when we talk about getting alerting products from the Defender for IoT solution. The recommended place for your staff to consume those and investigate those IoT incidents is the Sentinel console. You can do it completely in the Defender for IoT product by itself, but again, the Defender IoT product by itself is about to become a subset of this overall suite that I'm showing you. So again, in the video, I think it'll be clear why this is so valuable, this integration. So we're going to go into our demo now, and hopefully things will be clearer, and then we'll wrap up. We're going to begin our deep dive into Microsoft Defender for IoT in this demonstration that includes integration with Microsoft Sentinel. We're going to begin at the building block of the solution, the most basic element, which is perhaps the sensor. We're looking at a desktop in my lab, and we have open in a PuTTY SSH session. We have the Defender, the login to the command line interface. You can log in locally to the system, and you rarely need to do this. You maybe need to do it during initial setup to set the IP address or the time, because time sync is very important to sensors when they take their initial configurations. You might need to come in here to this command line interface. Sometimes we can do help and see what our options are. We can see there's network and system areas that are sometimes helpful. I'm going to go to the system, do help again, so you can see the options there. There we go. You can set the date. Sanity is a good health check to run. What I'm going to do now is I'm going to do shell, and that's going to take us out to the Debian Linux OS, and I'll just show you that it's the file system. You never come in here. We treat it as a black box. We don't mess with anything in the Linux OS, but I'm just showing you everything, including what's under the hood, right? If we go to the home folder, we can see that there's a username named CyberX. And the first time I saw this, I wondered, what is this? So I'm going to quickly segue out. We're going to talk about where this product came from and where it's going, and then jump back into the lab. So here's an article still in the Microsoft blog from 5 years ago, when Microsoft purchased a small company named CyberX, about a 200 employee outfit from Massachusetts, which had written the product that became Defender for IoT. So Microsoft has been sitting on this and working on it and developing it for about 5 years. It's a relatively new Microsoft product, but it continues to show investment. And so that's where it came from. And where it's going is here. This is the Microsoft Defender XDR portal, security.microsoft.com. Those of you that have a Defender XDR, subscription, you may be familiar with this view. This is where you administer your Defender for endpoint and such. So the Defender console, the security console, is the destination for all the Microsoft security services and platforms, such as Defender for Identity, Defender for Cloud Apps. And also, you can see Microsoft Sentinel is coming in, and basically the Microsoft Sentinel SIM is being fully integrated into this portal, and Defender for IoT is on a path to be integrated here as well. In fact, if this is a different environment, but if I had in another environment where it's configured correctly, there's another line item here for operational security, and under there, like everything that we're seeing today in the Defender for IoT console, just like all this stuff under here in Microsoft Sentinel, when we go into the Sentinel in this demo and we look at the workbooks and we look at the incidents, we're going to see the same things in Sentinel that we see here because it's Microsoft is bringing all the products together, and for very good reasons, but technical reasons and cybersecurity positive reasons. So it's a good thing. And when I'm describing the solution to you today, it's in this context of Defender for IoT living within the entire Microsoft security ecosystem, which is quite broad and quite deep. And so your Defender for IoT devices, your OT security is managed homogenously in concert with all of the other IT and cybersecurity demands, essentially from a single console, which is the Defender XDR console, is the destination. So that's sort of where we started with the CyberX acquisition and where we are today with the continued investment and growth of the product and rolling it in along with Sentinel into Defender solution. So now popping back to our lab. So we took a look at the sensor, from logging in to the command line interface. But generally, when you're going to log into the sensor, you're going to be using the web interface of the sensor. So here we are, different points of control. We saw briefly the logging into the sensor's command line. Now this is the web interface of the sensor. Every IoT sensor, whether virtual or physical, has this web interface as a way to administer each sensor locally. And there are a lot of features here that are duplicated in the central console in Azure. And so everything that can be done in the central Azure console or in the Sentinel console, we're going to do it there. And we're only going to go through the trouble of getting onto our local network and logging into these individual sensors when there's specific tasks we need to do. And I'll point those out to you. Like I say, you'll see in a moment when we look at the device inventory in the Azure portal, it's going to look identical to this, right? When I click a device and I get a flyout on it, or I push the edit button to edit its properties, you'll see that these are identical experiences in the Azure portal. While there is an alerts feature here, we highly recommend that Microsoft Sentinel be your destination for alerts, and so you'll almost never come in here and use the local alerts on the individual sensors. The most significant thing that's on the individual sensors is the mapping. This is not a feature available in the central console, but it's very high value, right? So maps will automatically be created for OT protocols, subnets, and VLANs, and also any attack simulations that you've run. You can optionally create a map for those. But most significantly, let's look at our process control and our supervisory networks, which are in the Purdue model. Each OT network ideally is going to have these. Our process control network being the most isolated, and this is where our devices are. And so you can see here, if we look on, what is this? This is a Siemens PLC, and this other device is a Moxa serial controller. So these are actual OT devices essentially on the shop floor, and this is our most protected subnet. Then we have the supervisory network, which is a little broader, and this is, for example, where our HMI and our supervisory workstations are. So there's our switch, there's our HMI machine, there's our engineering workstation machine. These are Purdue model duties, involved in managing OT network devices. And so you basically out of the box, you're going to get maps for each of these VLAN and subnet identities, and then you can create custom maps. And in a large environment where there's thousands of devices, this is extremely valuable. And you can see by protocols, some customers they have doubt about what protocols are being used by what devices, and so by creating maps dedicated to each of these, they allow you to study what's happening on the network. It's an extremely powerful and useful feature of the solution, and it's only available locally on the sensors themselves. So the device map is a main reason to return to the sensor itself. Another one here is the event timeline. Now, something that the Defender for IoT product gives owners is deep insight, a lens 24/7 into what's happening on the network wire, right? And at the very top of the sort of the incident chain, food chain, we have like Sentinel incidents, which are the things that your OT SOC tickets are going to work from. But at the beginning, we have events. So this is everything being sensed on the wire by the sensor, and only a fraction of these things are of potential security interest. And so many of these events do not raise alerts. But this gives you the ability to watch everything happening on your OT network and perhaps decide that an otherwise routine or what other people might consider to be a low priority uh, uh, event is very important to you. You know, for example, here we have a file transfer connected. The Defender for IoT observed FTP in progress between two devices. In your environment, you might have no FTP is permitted ever whatsoever because you have security protocols and procedures that avoid the use of it. So this, you might want to raise an alert if FTP was ever detected in your environment because this means it's something you're not expecting, right? So the event timeline lets us decide to promote events to alerts, perhaps. When we look at the system settings, I'm going to briefly show you this. We have things like the subnet settings, the time zone settings, management features like connectivity, and so a lot of these things that are here in the sensor settings are duplicated in the central settings in the Defender for IoT portal, and so we don't set any settings on the individual sensors. We set all of our settings in the central portal, and they're inherited by all of our sensors. So that's kind of a view of the local sensor and things that are uniquely there. Yeah, one other thing I wanted to point out: this risk assessment is very cool. So this is we can generate a risk assessment anytime. Do this, for example, monthly, and it's a attractive, easy to read PDF report that summarizes everything happening in that particular sensor's environment. So this is not comprehensive for all of the sensors in your subscription, but each sensor produces a very readable, understandable vulnerability report, risk assessment report specific for that sensor. And for example, in this environment, this lab environment, I've got 3 Microsoft machines that have vulnerabilities found. The Moxa serial controller and the HP switch, they have no vulnerabilities. The Siemens PLC, it does have vulnerabilities. So you can see this type of stuff gets preserved in this PDF report, and the thought is that if you, for example, do this every month and then save these PDF reports, as it can be evidence to auditors of an effective ongoing OT security program, as well as providing, I guess, something readable to your stakeholders and an executive suite to show that you have a positive handle of what's happening in your OT environment security-wise. So now let's head over to the Defender for IoT portal. So now we've looked at the local sensors command line interface. We looked at the local sensors web interface. Now we're going to take up to the next step. Now we're in the Azure portal in the Defender for IoT solution, where we see all of our sensors from all of our sites and all of our devices discovered by all of our sensors rolled up into one place. So I'm going to start here at the sites and sensors, and you can see in this lab environment I have one sensor. And when I go to the sensor overview, it's very similar to what I saw when I logged on to the local sensor for its overview page, right? So you're going to see all of your sensors here, and this is an important thing. You have your licensing. So as I covered in the slides earlier, you'll need to purchase one or more site licenses for each device, or for your devices have to be assigned to a site license. You can have more than one sensor in the same site, and they share the license for that site. So in this lab environment, I have what's called the extra small subscription, which allows me to manage up to 100 devices. Now I mentioned the device inventory remember I showed you this view on the local sensor, and I said it's almost identical to what there is in the web view, and you can see here I was right. Okay, so and when I pick a device, I get the fly out over here, which confirms what protocols it's active on. The Defender for IoT automatically assigns a tag for the subnet that the machine is on, that the device is on. And just like in the local sensor, I have an edit button here. And so here I can override the class or the type of device that was discovered. I can add other remarks. I have a lot of freedom to create and leverage basically metadata for all of my devices. You have complete control of that. you can see when we pick a device and we go to edit it, we have a couple of options that we can say that this is a programming device. So if this device is expected to be sending programming commands to other devices, then we can designate it as a programming device, and that will avoid alerts about unexpected programming command sources. So here's, you have your inventory management features, which are outstanding. So a concept to appreciate is that you have both local and routed connections. Okay, so the Defender for IoT sensor is listening on that wire on the process control network, and it's going to detect all inbound and outbound connections, whether those connections are on the OT networks or not. And so those that are in the other networks, the non-ICS networks that still somehow are getting routed connectivity into that ICS subnet, those devices are still discovered so that they can be monitored and analyzed as potential threats. And those devices are called routed. They're called routed when they don't reside on the ICS networks themselves. There is an alert feature, just like the local sensor had an alert view of its own alerts. There's also, of course, a rolled up view of all alerts from all sensors. And I recommend that you use Microsoft Sentinel as the single pane of glass for all of the incidents. But there are times that you would come in here and look at the alert stream in the Defender for IoT app. So, and one reason is to create suppression rules. Okay, so to groom the alert stream, there are certain situations. For example, there's certain alerts that you may just not be interested in receiving, or maybe certain alerts that come from certain sources. You've already investigated them. You've discovered that they're benign positives, and so you can create a suppression rule in the Defender for IoT Azure portal that will suppress all the alerts from all of your devices. So you're essentially managing all the alerts at once in one place. Again, we don't want to use the alert consoles on the individual sensors. We're going to use the single consoles up in Azure. The one here for the Defender for IoT, and then one we'll look at in a minute for Sentinel. And so you'll come here to the alert view on this in the Defender for IoT portal. For one thing, is to create and verify suppression rules. Because we want to suppress them here before they make it to Sentinel. That's a grooming tip, right? And then another reason that we might want to come here to the Defender for IoT Alert Console alone is to investigate further exact things that happen. So if we go to an incident here in the IoT portal and we go to alert, there's this very valuable button here that says download PCAP. A PCAP is a network trace. Those of you familiar with network tools like Wireshark, that's the native format for exchanging network traces. And so Defender for IoT, the sensor captures the network trace of the traffic that triggered this incident, and you can look at it. And so I actually have one here preloaded. So if you'll download the PCAP, it'll show up over here, in the regular download area. You'll click it. If you have something like Wireshark opened, it'll open up. And now here we're actually looking at the on-the-wire traffic between two devices on the OT network, and we can see, like we might have, like when your top level alert might have told you that the reason that there was a failure here was because the client device got a forbidden response from the server. But by actually cracking open the packet and look at it, we can see that the device tried to get this particular file from the server, and the server replied that the client was forbidden to get that file. So here, you can see that we were able to dive right into the raw network wire traffic and very rapidly diagnose exactly what the problem is, and then we can go to that vendor or we can go to that team and say, it's because of the file access issues with this particular file, and that will really speed the resolution. And the final reason that you might want to come to the alerts console is, as we'll see in a second, in Microsoft Sentinel, we don't create an incident for our OT SOC to investigate for every single alert in Defender for IoT. We select the Defender for IoT alerts that are most important and critical, and those are the ones that we have create incidents in Sentinel. And so another reason, just like you might go to the raw event stream on the sensor itself to see if there's something happening that's so interesting to you that you want to make a custom Defender for IoT alert from it. You might do that, and then that custom alert is going to show up here in the Defender for IoT alert view, and then you can take that and essentially copy the logic into Sentinel and create an incident for that, so that your OT SOC will get instant alerting of that particular event that you discovered on the sensor that you want everybody to immediately begin investigating if that happens again. Some other features that I definitely wanted to show you here from the Azure portal, there is a recommendations area, and this recommendations area is going to be comparing the threat and vulnerability. It's going to perform a threat and vulnerability analysis against all of your discovered items and let you know the most important ones, right? And in this case, we've discovered that these particular devices are operating in an unsecure PLC mode. That, in other words, the controller is vulnerable to insertion of commands that the admins would not want, right? And then also here, Rockwell devices in the LAN, like there might be 100 Rockwell devices discovered, in the plant, but only in this case these 13 have highly vulnerable firmware issues. So this recommendations area calls out the most important, most actionable issues that you might need to work on to improve your security. There's a fantastic workbook view. We'll take a quick look at this vulnerabilities workbook. Our OT customers report that this is very valuable because by assessing the risk from the CVEs, and these would be the IoT CVEs specifically, they're able to prioritize what to work on first, and they're able to cost justify their work projects to their FinOps people because if in a large environment, fixing one of these CVEs might require a good number of man hours. And so this helps the company that nobody has an infinite number of man hours. And so this helps you prioritize what to work on first and what will give you the most bang for your buck, essentially. So the visualizations and workbooks out of this are outstanding, and even more so outstanding in the Sentinel product. I'll show you in a second. This is very useful. A few years ago, there was a super renewed interest in supply chain issues. And so Microsoft added this. This is an example of something that Microsoft has added to the product since they bought it from CyberX, is this firmware analysis. And so here I've uploaded some firmware. This is for the Raspberry Pi OS Lite edition. And it's been analyzed. And Defender for IoT found some vulnerabilities in this out-of-the-box Raspberry Pi OS. In fact, 7 critical and 59 high priority weaknesses. So you might think, if I take an off-the-shelf Raspberry Pi and deploy it, it's actually not secure at all, right? And maybe people know that, Raspberry Pi is not designed to be, it's designed to be highly protected, on a device. But I wanted to demonstrate, if you might have, Rockwell or Siemens or Hitachi devices, and you would get a new firmware image, and you want to make sure that there has not been an attack on the supply chain. You want to make sure that the code is valid, and so this is a way for you to upload that IMG file, the same one that you're going to put on the little data module to program the PLC with. You can scan it for unexpected, unusual items and for vulnerabilities. So it's very high value. You can tell your customer, you can tell your stakeholders, we are doing something to validate the supply chain in the firmware used by our OT devices. That's a significant capability. So I think I covered a lot of the things that I wanted to cover from the sensor itself. Now let's turn our attention to sort of the last piece of the puzzle, which is rolling up Defender for IoT behind Sentinel, right? And we connect Sentinel to Defender for IoT first by going to the Content Hub, and we search on Defender for IoT, and you can see that we have analytics rules, playbooks, and a workbook. Okay, so the analytic rules, I mentioned that the are a selected subset of Defender for IoT alerts, for example, you know, suspicious malware found on the network. That's a Defender for IoT alert, one of the hundreds. And Microsoft has picked like the top 15 most significant, most dangerous alerts that might come out of Defender for IoT and pre-staged these incident rules, right? So that's one of the products. There's also a fantastic workbook that we're going to look at, and some automation playbooks that we'll look at. So that's how we connect our Sentinel to our Defender for IoT. And then now this is really the point of it all, is we have our Defender for IoT incidents in our Sentinel console. Here we go. So now you see we're filtering on Defender for IoT incidents in the Sentinel console, and here we've got an instance. So this is what I recommend. This is the best way to prosecute and investigate your Defender for IoT incidents. It's not on the Defender IoT sensor itself. It's not on the in the Defender for IoT portal pages in Azure. It's in Microsoft Sentinel, the Defender XDR SIEM. And when we go to investigate this in our Sentinel, of course, we have these very sophisticated investigation tools, which I'm not going to get into, but it's, for those of you familiar with Sentinel, this is a very valuable graphical investigation space, and we have all the benefit of similar incidents. We have, investigating our entities. This device on the network was talking to this device on the internet. What is that device on the internet? Well, it's in an Akamai data center in California. This is actually a Microsoft data center. So that was not a hostile IP that was doing those bad login attempts. We don't know what it was, but we know initially it's not a super bad malware site, black web site type thing that it's been talking to, right? So we can rapidly do those investigations in the Sentinel portal. I showed you the workbook that came, the vulnerabilities workbook that was in the Defender for IoT product. This is the IoT security workbook in Sentinel, which is, I think, even more powerful. That we're going to have basically rolled up reports in here for customers that manage by MITRE attack vector. This is a easy, on the screen, what's the first thing I should work on? It's right here. It's very clear. This particular MITRE attack is I'm much more exposed to any of the others. So, the vulnerabilities organized by CVE. So this workbook, which is a dashboard for the OT security team, part of Sentinel, super valuable. Another Sentinel feature that is extremely high value is the addition of the user and entity behavior, which you can see includes IoT devices, right? The Sentinel entity behavior analysis is analyzing our users, our computers, our IP addresses, and also our IoT devices. And so, when I click one of these, then I basically can fully investigate what kind of this device, past events of this device. I have basically a time view into everything that Sentinel has ever seen with this device and its potentially anomalous or dangerous interactions with other devices. So the investigation features, the dashboard features, the machine learning features that create the behavior analysis, these are all possible because of the integration with Sentinel. And the last thing that I'll show in Sentinel is the automation. Again, this is another why use Sentinel, because it adds the automation. And when we understand that roadmap, the Defender for IoT is moving into the Defender XDR portal. Everything that I'm showing you that's in Sentinel now will essentially be a native functionality available to Defender for IoT when it's fully migrated to the XDR portal. So by deploying Defender for IoT today in full awareness of everything available in the Microsoft Security Suite, and that is the destination for the Defender for IoT technology itself, we can deploy a rock-solid, world-class product today, right? And another thing that makes this solution world-class is the automation. You can see these automation rules that are set to automatically fire every time an incident comes in. For example, this automation rule is running a playbook that adds geotags to any public IP that can have a latitude and longitude associated with it is done, and then a lookup of the closest city and country to that, and then a tag on the incident. So this is an example of alert enrichment. And when we look at our active playbooks, these are the 3 playbooks that are imported when you integrate Defender for IoT with Sentinel. And these playbooks are performing synchronization. Those of you that are familiar with Logic Apps or Power BI will recognize how this work how this looks. That we take a Sentinel incident and we right away ask, does this incident have Defender for IoT alert content? And if it does, do this and that. And so these 3 Logic Apps are actually, they support bidirectional alert synchronization between Sentinel and the Sentinel console and the Defender for IoT console, so that your team might be, one part of your team might be investigating the incident in the Defender for IoT portal because they're looking at the PCAP, they're looking at the network information that's not available in Sentinel. But then another team might be working in Sentinel, and whichever team has developments and changes the status and updates the alert in their respective console, these playbooks coordinate those changes and synchronize them so everybody sees the same picture, no matter which portal that they're working in. So, and I did write a blog article that summarizes this all up. This is the blog John Joyner.net article on Defender for IoT from a couple of months ago, and it specifically talks about how Sentinel and Defender for XDR integrate with all the tools that I just showed you with the basic Defender for IoT product. It was really fun for me to demonstrate the Microsoft Defender for IoT product and solution today to our viewers at Cyber Back to School. So I hope you enjoyed my session. I hope you watched other sessions this month in Cyber Back to School, and safe computing.